Jon Skeet, who come use us as guinea pigs before his code match talk.
You're live.
Cool. I haven't seen any versions that are in binary form with no common text representation, and they're almost always ASCII. Things like a git hash are logically just binary, but we always represent them as hex instead. They may or may not be human memorable. Git hash is fairly obvious in not being memorable, but other ones here, many of us could say which version of C# we're using without having to look it up. Excuse me. And as I mentioned before, they identify something. Usually, this is where later on I'll come back to network APIs and how talking about a version of a network API may not always mean exactly the same thing under some schemes. But certainly, if you are getting a NuGet package, it would be a bad idea for NodeTime 1.2.3 to return you something different today than tomorrow. And certainly an awful thing if it returned you something different on one MyGet feed to on a NuGet.org feed. I've mentioned they may be partially ordered in time, so with semantic versioning, you would always know that, say, 1.2.3 came before 1.2.4, but you wouldn't necessarily know between 1.2.3 and 1.3.0 and 2.0.0. So anything beyond a patch level is kind of, you may have a suspicion about the ordering, but it won't be guaranteed. Having said which, of course, if you've got 1.1.0 and 1.2.0, if the patch levels are both 0, then you can go just by minor version. Okay. There can be aliases, so for Debian 9, anyone has the alias for Debian 9? You've probably seen it. Yeah, so that's stretch. In particular, in Travis configurations, you put trusty or stretch or whatever for versions. So that's just another human readable name for something. And there can be separate names that are, as you say, for marketing purposes. So Visual Studio 2017 for Visual Studio 15, and Visual Studio 2019 for Visual Studio 16, and Java 5 for Java 1.5, and yeah, Java is particularly bad for this, having the separation between marketing and non-marketing. Visual Studio is not so bad because 2017 is significantly different from just 15. Okay, I've talked about we can version libraries and platforms and things, but also applications, operating systems, pretty much everything to do with computers is going to be versioned in some way or other if it ever changes. And even things that you might not expect to change sometimes do. So you might originally naively think that Unicode is just one thing and is always the same, but no, Unicode evolves over time as well, so there are different versions of Unicode. And protocols as well, so HTTP 1.0, got HTTP 2.0, etc. Okay, I have a more concrete example of sort of lots of versions within one context. I'm getting rather hot, so I'm just going to hoodie. So this was, I believe this is accurate. I could have just made them up and hoped that they were right, without much fear of someone happening to know. But I believe this is correct. So the desktop framework, we can mostly ignore now because, for non-legacy things, you're not really starting with the desktop framework. But .NET Core is versioned separately between the SDK that you download or the runtime that you download, but the SDK contains the runtime, and there's this interesting, not quite semantic versioning going on where there's 2.2.200. If they do a new feature release within .NET Core SDK 2.2, that would be 2.2.300, whereas 201 would be a patch level. So they effectively wanted 4 levels of versioning, but semantic versioning doesn't have that, and they kind of went, yeah, well, it kind of works. So that has a runtime that also has a version, and then we have this interesting thing of .NET Standard. Now I don't want to teach my grandmother to suck eggs, so to speak. How many of you are familiar around the difference between .NET Core and .NET Standard? I think there are probably few enough that it's probably worth just going through. So .NET Standard is the common set of APIs that you would usually target for a library. So NodeTime 3.0 will target .NET Standard 2.0, which says any platform that supports .NET Standard 2.0 or higher, notice time should be fine on. And .NET Standard 2.0 is supported by .NET Core. It's also supported by the desktop framework. It may also be supported by a particular version of Xamarin, or in the future Unity. There can be different platforms that all support the same version of .NET Standard, and I tend to think of that as different classes implementing an interface. There have been a few different analogies for this, but yeah, so if you have .NET Standard 2.0 and then .NET Core 2.2.0 implements .NET Standard 2.0. I was in a meeting about how we decide the next version of .NET Standard. The meeting that I was in only lasted an hour, but that was after lots and lots of discussion offline, and I believe many, many discussions within Microsoft as well. Because if we go to 2.1, that will confuse people who would expect .NET Core 2.1 to support .NET Standard 2.1, which it doesn't. We could go to .NET Standard 3.0, but that would have the same problem with .NET Core 3.0, which will actually, I think, will coincide this time, but may not in the future. We considered .NET Standard 2.3, where there's never expected to be a .NET Core 2.3, so there will never be a collision. In the end, we decided to go with .NET Standard 2.1, and you just need to get over the fact that there is a .NET Core 2.1 that doesn't support .NET Standard 2.1. They are independently versioned things, and you need to get over it once, and then you can just keep living your life. I just don't have some strepsils in here. You would think that with the amount of speaking I do, I would have sorted my voice out so that I wouldn't go hoarse quickly, but apparently not. So this is just the .NET Standard discussion is just one example of how these things can be surprisingly difficult to get right for the sake of users. Because people have expectations, and however clearly you try to document how people should actually think about the versioning, the chances that they will are slim. Because we're all busy people, we have other things to do. Okay, rather than reading your document about how you're going to do versioning differently to everyone else. And this is part of the point of this talk is think about how you version things, try to understand what other people are doing, but make it as easy as possible for other people to understand what you're doing. And then at the bottom here, yeah, we've got the whole 2017 15.9 happens to be the latest version. I honestly don't know the relationship between the Visual Studio versions and the .NET Core versions. Could you use .NET Core 2.2 with 15.0? I don't know. I suspect you couldn't use the C# 7.3 things, or maybe it would build but wouldn't syntax highlight properly. Who knows? Let's talk more about semantic versioning. So, this is an example of a semantic version. Tell me what you know about semantic versioning. You know things about semantic versioning, I'm absolutely sure. Go for it.
Major, minor patch.
Major, minor patch. So this is major version 1, minor version 2, patch version 3. What does that mean?
You're guaranteed not to break anything with a patch.
Right, you're guaranteed not to break anything with a patch. I will assert that while that's the intention, it's never going to be valid, but we'll come back to that. So if we go to 1.2.4, that should be compatible. What about 1.3.0?
That is a new feature, but non-breaking.
New feature but non-breaking change, so that should be compatible as well. So why do I care about a patch? Why don't I just make everything a new minor version?
If it's not a feature, it's more of a bug fix.
I'd say it's more than that it's not a feature, so that you shouldn't be adding anything into the public API at all in a patch release, because patches are sort of forwards compatible as well. If someone upgrades from 1.2.3 to 1.2.4 because you fixed a bug, and then it turns out that your fix doesn't work for them, makes things worse, they should be able to roll back to 1.2.3 and it should still build, it should still work modulo the bug that you have fixed. They should be able to go back to 1.2.0. So you can go backwards in time with patches, whereas you can't necessarily. If you could map against 1.3.0, it might work against 1.2.3, but I'm making no guarantees about that at all. And obviously, if you've used a new part of the public API, and then you build against something that doesn't have that anymore, it's going to fail. What about major version? What can I do when I go to 2.0.0?
Anything you want.
Anything! Yes, correct. Yeah. There are no guarantees whatsoever. So I could go from the main namespace in Nodatime being Nodatime to time zones are awesome. Whatever I want. I could rename absolutely everything. There are no guarantees. So, turns out you knew about semantic versioning. At least, apart from what does it mean at all to be compatible? Compatible is all about what you're communicating with your clients or what your providers are communicating with you. So it depends on your context. If you are building an app, you need to know how your dependencies behave. Is it safe for me to upgrade this dependency? Maybe it's got a new feature, maybe it's got a bug fix. Is it safe to do? If you're building a library or a network API, you need to know what the people upstream of you are expecting. And these aren't isolated concerns, because if you're building a library, people will be depending on you, and you may well be depending on other libraries as well. And again, libraries and network APIs aren't quite the same thing. I build libraries that depend on other libraries and call in network APIs, so I can't control, in the Google case anyway, which I'll explain in a bit, I can't control whether or not servers have updated. I'm calling the v1 API. That may give me back more information than I expected, because its definition has changed. So I need to be aware of that when I'm building the library. That means that you should not expect one answer to fit all the cases, so I'm going to avoid making too many recommendations in this talk. But do bear in mind that basically you need to think about it for yourself. Who is assuming what about my code, and what am I assuming about other people's code? If you build code, and I did for several years at Google, I wrote Java code that was only used by other code within Google, and we were all building from one monolithic repository, always at head. If I knew there were no callers to a particular method, I could just delete that method. That's safe to do. That's a lovely, lovely situation to be in. It's not really viable for open source. How many of you have published NuGet packages? How many of you look at the download numbers every so often? I certainly do. It's entirely reasonable to say, how many people are using my library. It's a shame that the download numbers, as far as I can see, there is no explanation of what they actually mean. If someone has a continuous integration for their application that uses NodaTime, does that mean that my NuGet.org download count gets incremented every night? Or every time they push or whatever? A metric that you don't understand really isn't terribly useful. You think a higher number might be better than a lower number? You generally want them to be higher. But it could just be one person who's building all the time and is building an app used by almost no one, and if I break them, it doesn't really matter too much. But there could be one person who has downloaded a local copy of the NuGet package and is then using it within all of IBM, and I break the world if I break their usage. So, even if I actually knew exactly what the NuGet.org numbers meant, chances are they wouldn't be terribly useful. So it's a big problem in open source that we just don't know how people are using things. If you're building a network API, then you're sort of somewhere between the internal use only and the external use, the open source usage, because you can see every request that comes into you. And if you don't have metrics for that already, add some. Because if you want to change an RPC, supposing it's an RPC-based API, if you have an RPC that you want to change because you made a typo in the name, and it turns out that no one has ever called it, ever, possibly because they couldn't find it because of the typo in the name, then it's probably reasonably safe to rename. If people, maybe depending on your logging and privacy concerns and things, maybe you can find out who those people are and contact them directly. You're in a better situation than the open source, or I don't know who's using it, status, but definitely not in the same realm as the this is all built internally. So, bottom line, you need to think about all of these things for yourself. That's where my point is gone. Okay. I've mentioned compatibility a few times now. Let's get back to it. So, let's assume about a library, and I'm only using this as an example. Obviously, I do want you all to use NodaTime, but this is not particularly a plug for it. What do you think we can do to the public API that won't break someone? Can anyone suggest a non-breaking change to the public API? Add something new. So what, a new method? New class?
New comments.
You can change the comments. Yeah, I would suggest that actually I would be mostly happy changing comments even in a patch level. Depending on the comment, but usually I would be happy with that. But adding a new method, no, because if someone might have an extension method targeting my class, and suddenly their code will be calling my method rather than their method. Could break them. Add a new class. Well, what if they've got a class as well, and suddenly they could have an ambiguity in the identifier? Any other things that we could do?
Put a private method in a class.
Put a private method. Yes, you can change that because that doesn't change the public API. Any other things to do with it? I'll assume you understand that if you remove a class from the public API, that's a very breaking change. But what else sounds like it might be compatible?
Extends, just don't modify.
I'm hearing a few things, so let's get them all. There was
overload an existing method.
overload. Oh, I'm so glad you said that. Because it's a point of great joy and sadness at the same time. So let me bring up Visual Studio at this point, and this will almost certainly mean when I go back to slides, I'm going to have to change everything, but I can't resist doing a bit of coding. So let's
chain a new constructor.
hang on. Let's do one thing at a time. But I like your idea of chaining constructors. That'll be fun. So let's do a new solution. Right. Okay. Getting there. So let's have a library. I'll adjust the fonts in a sec. We'll have a library project and an app. So app. And this is the bit that I won't get to do at CodeMash because I've sort of done this as a mostly language agnostic thing. So details of C# are less permissible than they might be otherwise. Right, so we'll have a library and the app will depend on the library. Add reference, library. Yeah, that is genuinely quicker than editing the CS project by hand, which is what I would normally do. But isn't it lovely that with the SDK style projects you can just edit the files by hand and you can understand everything within them. Right, is that readable at the back? Yep, okay. So, in our library, class 1, we're going to have, give me a method signature that will overload. Foo is always a good name. With any parameters?
Hello string.
So, I heard a string. Okay. Woo. Yeah, it's the Shift Enter is doing weird things. This always happens. This is a new laptop, and I have yet to configure it so that my common mistake of hitting Shift Enter instead of just Enter doesn't do whatever weird thing that just did. So let's write some. I'll just make it static for the moment. Take it from me that by the time you add inheritance and generics in, all hell breaks loose basically. But we'll ignore that for the moment. So class 1. Thank you. Did I not already? I did. Okay. Right. So class 1 dot foo. Okay. What overload are you proposing that we add that is backwardly compatible?
An int.
Just, I'm going to have to fix that soon, before I next demo to anyone. Right, and with that code, that's correct.
Feels safe.
Yeah, because what expression could you possibly give that could be compatible with a string and an int? Well, I could have class awkward type that has now. Is that the syntax for implicit conversions? This is something that's, it's operator, int. Okay. There we go. Right, so now, new awkward type. That wasn't ambiguous before, but now is. And that's always been the case. Okay, that would always been ambiguous. But C# 7.2 or 7.3 makes it far worse than that, because we don't need a new type at all. We can just use the default literal. And that's now, is that a default of int or is that a default of string? It was fine before, when it only had to know whether it was compatible with string. It's possible that adding an overload, either adding a parameterless overload or adding a parameterized overload when previously there was only a parameterless one, I think that may well always be okay. And if you don't have any optional parameters, then in general, adding another overload, no, even that's not.
Well, if you had a string and then you added an int, so you were matching your previous signature and just extending.
So long as neither is optional, I think in most cases, if the arity is different in terms of the number of parameters, that's usually okay. However, I'll just prove that it's not always. And this is, okay, partly this is because I enjoy this kind of thing. Okay, I'll readily admit to that. But there is another reason for showing you all of this, all of these shenanigans. Function X. Just stop. Okay, so currently we have just a parameterless method, and I think I can do perform action class 1.foo. And I believe that will compile. But as soon as I add the parameterized method as well, now the method group conversion of class 1.foo to action or action of int is ambiguous. So yeah, even if you've got different numbers of parameters, you can have, the problem is that there is this generalized idea of, I will have a reference to the method foo. Well, which method foo? Well, it's got to be unambiguous already, otherwise there's a problem. I won't actually go into constructor chaining. Oh, did you have anything particular in mind for constructor chaining that was interesting? I mean, that's normally an implementation detail rather than public API anyway. Although, interestingly, there is a difference between the class as it is and public program. Admittedly, not with. I have been using this for last week and just not run into this. I don't know what's happening. So, if we were to extend some other class, then you might think that that is exactly the constructor that's provided by the compiler already. But if the base class has a constructor with a caller member info that has a default that is optional, then this explicit call to it fills in .ctor, and the implicit version like that doesn't under Roslyn, it does under Mono. Yay. I think that's personally a bug in the C# specification, which says that it shouldn't. It's like, no, those two things should be the same. But the reason this was particularly interesting, using the default literal, and also for extension methods, it used to be that changing a static method from a static method in a non-generic top-level static class, changing that from a regular static method to an extension static method used to be a non-breaking change. Using static directives in C#6 have some, I can't even remember offhand what it is. I think it's, if you've got using static, then trying to call an extension method as if it's a normal method doesn't work, whereas calling a regular static method does, which means that if someone makes it an extension method, that is now a breaking change. So I could have released NodeTime 1.1 and then NodeTime 1.2 and say that's fine, or sorry, 1.1.1. You know, it's not a breaking change. No, it would have to be 1.2 because even making it an extension method is effectively changing the public API. It's changing what you can do with it publicly. But it would have been fine as, hey, this is a non-breaking change, 1.1 to 1.2, and I could have done that in 2008 when we first got extension methods. But C#6 has retroactively made that a breaking change. Okay, so trying to reason about versions is like playing n-dimensional chess, where n is the number of things that are versioned within your system. There's the language, there's the platform, there's the version of NodeTime, there's the version of any other dependencies you have, and things get weird. So this is why, you know, we all know what semantic versioning is meant to mean in terms of compatibility and things, and I'm saying that that is basically, if we think that that actually solves everything, we're kidding ourselves. Right. Let me just see if I can. No, I think I need to start again. Oh, that's it. There we go. So, I don't want to abandon semantic versioning entirely. You know, it's not like every version of NodeTime has gone 1, 2, 3, 4, 5. The point is that saying I am backwardly compatible is really I am backwardly compatible in these ways. You know, if you haven't done weird things like a method group conversion to an overloaded method so that if I do any overloading, you're completely messed up. If you don't do those things, you're okay. Another example, before we had default, you could have a method accepting a string and a method accepting a stream, for example, or a string builder, or some other type that isn't string. And leaving aside custom conversions as well, the only value that is compatible with both of those that you could provide that would be ambiguous would be null. Now, if both of my methods say I do not accept null, I'm going to throw an argument null exception anyway, then maybe your policy can be, do you know what, I will give you that error earlier on. I will turn what was a runtime error into a compile time error, and that's a good thing. You know, if you call foo with an argument of the null literal, then it's gone from being, oh, you've done something stupid and I'll throw an exception, to you've done something stupid, I won't even compile because it's now ambiguous. But you get to decide that policy. I have seen the .NET GitHub repository, for want of a better organizational phrase, has this is what we consider to be a breaking change and not. I don't think it goes into excruciating detail, and I don't expect any of you to either. But I do expect you to sort of think about it and realize, okay, I'm making a public API change. How much do I care about people who already have a class named this in their own namespace? You know, can they fix it easily? Is it going to actually cause problems? The other aspect of compatibility that we haven't spoken about at all yet is the difference between binary compatibility and source compatibility. Source compatibility is usually if I can recompile all my code against the new version and it still works, then that's source compatible. If I can run my existing compiled binary by someone dropping in a new version of the library they're depending on, literally copy the new DLL, put it in place, no recompilation. If that works, that's binary compatible. One of the really interesting things about in parameters in C# 7.3 is that changing from a value parameter to an in parameter, i.e. something with no modifiers to the in modifier, is a source compatible but not binary compatible change. Changing something from a ref parameter to an in parameter is a binary compatible change but not a source compatible change. If you have an existing method, you can't make one of them in a way that is both source and binary compatible. It just doesn't work. So that's things to think about if you are trying to be compatible. But what about situations where you're just not going to be compatible at all? And this is where I wonder why the world hasn't already collapsed a bit with the diamond dependency problem. How many of you are familiar with if I say diamond dependency problem, how many of you go, oh, I know what that is? Okay, very few. This is good. This is good. So, this is one version of it. We have an application. The application's version really doesn't matter at all. Because it's not a matter of the application evolving. This is just a snapshot in time that is already causing problems. We have library X that, whether you know or care or not, I don't know, depends on library Z. You also depend on library Y that depends on library Z. So, realistically, in the real world, this is always JSON.NET. Everything in the world depends on JSON.NET sooner or later. Okay? I don't think I need to labour that point any further. But hopefully you can see the problem here. Library X depends on 1.2, library Y depends on 3.2. 1.2 and 3.2 don't have to be compatible at all. They don't need to have a single type in common. Which version of library Z is going to be loaded into your process? I believe with the current way that at least .NET Core and NuGet and things work, it will be 3.2. And Library X gets to take its chances and be the little library that could, you hope. And hope it doesn't call anything in Library Z that's been removed since 1.2. That's probably the most common way that the diamond dependency, and it's called diamond dependency because if you imagine this is Library Z with both 1.2 and 3.2, and we've got a nice diamond. You can do it more simply because your application may directly depend on Library Z 3.2, and it's just that you have a dependency on Library X that depends on Library Z. .NET does not currently, as far as I'm aware, have any way of fixing this. We're at JSON.NET version, I think 12, maybe 13 now? How have we survived? Fundamentally, I think it's that JSON had that many changes that are genuinely breaking. I suspect that James is a smart guy, and he has done minor releases. So I'm pretty sure it's a matter of he has been very meticulous, saying, okay, I've removed an enum version that turned out no one was using at all, but I removed an enum value, so I will make it, give it a major bump. But this is fundamentally a big problem. Because let's face it, the number of libraries and versions is only going to grow over time. And chances are you're going to want to use something that no one's updated for a couple of years that depends on an old version of JSON.NET or whatever it is. And while James may have been very nice about mostly only removing things that no one was using, if you try to use NodeTime 2.0 from something that depended on 1.0, you may very well have problems, because I had a couple of things that were fields before and are now properties. That's a breaking change. If something in binary form depends on it being a field and tries to use load field instead of get the property, then it's going to go bang. I want to talk to the .NET folks about this at some point, because I think we need better ways of talking about these. If Library X never exposes in its API any types from Library Z, it would be nice if it could declare that that's a private dependency that should be still deployed. This isn't like the private assets equals all, that is, don't actually include this anywhere, I don't want final applications. The application should still have Library Z, but it should load both 1.2 and 3.2 into the same process, into the same app domain, not that app domains really work in .NET Core anyway. I believe that mechanism still exists, the ability for the CLR to load multiple versions of the same assembly, but there's no way of expressing it that I'm aware of in project files. And there's definitely no way in the C# language of saying, hey, I've got this dependency, but compiler, please tell me if I ever expose it, because I never want to. And the reason it's important is that if I'm using Library Z, and this does expose something, maybe, let's take a concrete example, nodetime.serialization.jsonnet. Okay, it's a small library that says, hey, I provide JSON serializers, and I accept a JSON serializer settings, and I'll configure that for you for looking like nodetime. So obviously I need a JSON.NET dependency, and I accept a JSON serializer settings or JSON settings or whatever it is. So I'm exposing a reference in my public API. If you're using a version of JSON.NET that doesn't have serializer settings or has only some of the members, that's going to cause a problem. So I can't have it as a private dependency, I would have to have it as a public dependency. At that point, maybe we need another mechanism, just like we have external assemblies, if you want to refer to the same type from different assemblies. C# already has a mechanism for that, but we don't have anything in the project system to say, I want to load library Z, JSON.NET, with this particular prefix, so that when I talk about that prefix, I'm talking about this particular version. If you could do that, then I could depend on library Z 3.2 and library Z 4.3 and whatever, and use them all independently. So as I say, I'm surprised that the world hasn't blown up yet. If we don't take any action, then I think it's likely to blow up before we fix it. And I've sort of expressed some of this to the .NET team before, and they're smart people, let's face it. They are smarter than I am. They know this is a problem as well, but I think we need a bit of pressure to make sure that everyone understands it's a problem, and then they might get pressure to fix it. Okay. Did I have anything else? Do you have any questions on the .NET specific side of things before I wrap up with a bit about network API versioning? Okay. So, when I've talked about network APIs today, I've essentially been talking about what I know and love, which is Google API services. You could talk about your own favorite REST API. I gather the Blue Cross API is particularly fondly known around here. But anything that you access over a network connection, and probably almost anything that you do over a network connection involves some kind of versioning. Almost everything uses HTTP, so which version of HTTP am I going to use? It's hard to imagine that there'll ever be a version of HTTP that is not in some ways backwardly compatible, so that if you type HTTP : it'll go, no, I can't even work out that you only support version 1 because I support version 4 and I can't detect version 1. But there are the different versions at different protocol levels, and different services can provide different API versions as well. So, for example, the Google Drive API is currently at version 3, the Google Spreadsheets API is currently at version 4. This is the sort of versioning that I'm talking about. Now, you can imagine there have been more than 3 releases of the Google Sheets API over the whole of time, because it's not like they do something and then do nothing for several years and then release a new version. And this is the sort of versioning scheme that we have been using or proposing. So Google's a big place. Different teams have been adopting the new ways of doing things at a slower or faster pace, partly depending on how much API reviewers have been nagging them. I'll say an experimental, this is in some ways all an experimental scheme. I've been writing this up in the last month. The idea is that the experimental version, of which there is 1 per major version, because if you have multiple deployments of experimental API versions, chances are you're doing something wrong, so we're trying to discourage that. That can change at any time in a completely backwardly incompatible way. Okay, nothing is guaranteed. Within 1 particular version number should stay compatible. Now, just that statement suggests something that doesn't compute when we were talking about library versions. Okay, I've said about within 1 particular version it should stay compatible. For libraries, that's a no-brainer. How could Nodatime 2.3.3 ever be incompatible with Nodatime 2.3.3? So it only ever means one thing. And that's where, for Google APIs, this is one option for network APIs, I want to keep stressing this, we handle things differently. So the most important version here is V1, but all of these can evolve over time, but only in backwardly compatible ways. So if you start using V1 Alpha 1 today, and then I make a change in it, maybe I'll return some more fields or have some more methods, these are RPCs, you should still be able to use your code and it should still work. I might have a V1 Alpha 2 that would not be compatible with the V1 Alpha 1 because, hey, we found out from customers that that call was useless, or requiring that field was really annoying and actually we just wanted to drop the field entirely. But within multiple releases of the same version, it should stay compatible. And the idea is this is roughly a life cycle diagram. So we have pre-general availability releases, then we hit V1, but this is the bit that somewhat embarrassingly, we didn't really we thought quite a bit about APIs availability. And then we kind of stopped and thought, that's fine, no one ever want to add features to an existing API. We didn't really think that, we just didn't think it through properly. We don't have a concept of a my version number. There's no version 1.1. When a new feature is added to the stable version, it will be version 1 again. Okay. The P1 here is meant to be sort of thought of as roughly version 1.1, but it's an alpha version. There are only pre-release versions of anything that isn't just a major version number. And then after a while you say, oh, like, we want to make actual breaking changes to the AI, so we'll start with V2 alpha 1. And then eventually get to a V2. V2 could, just like any other semantic version, be entirely different. There's no guarantees of compatibility at all. Now this raises an interesting question for libraries, and that's where I get particularly interested. So I'm providing a package for V1 of, say it's Google Cloud Storage. Okay, what should that NuGet package be called? I could just call it Google Cloud Storage and call it V1, as in release version 1 of it, but that suggests that it's my library which is stable, has a stable public API from the C# perspective. They've got to their. Likewise, I may, and in fact I have, made breaking changes, so I've wanted to release a V2, but their API hasn't changed. So it would get very confusing. I did the thing earlier on. I took the confusion hit by reading API version within the name of the NuGet package and in the namespace. So it's google.cloud.storage.v1 version 2.3. Okay, so that's version 2.3 of the library that talks to Google Cloud Storage v1. That's not so bad. I think it will cause a bit of confusion later on when we have version 1 of Google Cloud Storage version 2. So long as you only have one version of anything, it's open. That has definitely caused some consternation for people, but I can't think of anything else that makes sense, because if we decided to just do a major version bump every time either we wanted to make a change or the API team had made a change, we were rapidly get out of sync with what the node folks are doing. API says we're on V5, nodes on V6. I don't think that's terribly sustainable. To emphasize, other APIs from other providers, maybe from your company, maybe Azure, maybe AWS, whatever it is, may use a complete different scheme. I believe there are some APIs that allow you to keep with the version that you know about, which is usually identified by date, whether that's on the URL or in a header or whatever, and it will only ever give you back fields that were defined at that point, and it's usually done by some kind of chain of, I'll take this request and transform it from you know about to, and there's only a server version of the latest version, and then that gives a server latest response, and then I'll filter that down to the bits that you knew about. Which sounds great until you end up with some fields that are sort of codependent, and I think runs into some problems there. But hey, guess what? If you're providing an API, you get to make that choice. more talk. The ultimate message is please think for yourself, because there are no easy answers. Which leads me to conclusions, which will be easier to make sure I've got them all. I can do. So, versioning is an area that affects all of us every day, and and that's not a great combination to have. Given that I've said we can't add overloads, can't add methods, C# is not really designed. C# was designed to some extent to be good for versioning. There are some areas of language which have been designed with specific really designed from scratch. Versioning is going to be a problem from the very beginning. I hope that whatever next generation language we have this sort of built-in and more composition and more idea of packaging built into the language rather than just an ecosystem that's kind of been built up around it from the start. Semantic versioning is the de facto standard in .NET, but it's not the only game in town, not the only option. You could version packages by date, version them just by git hash. That still has it just doesn't have this idea of complexity that sound is in theory awful and in practice the ideal and the terrible. You know, the world hasn't fallen apart. We have managed, and we mostly know. You know, when was the last time? Genuine question here. When was the last time any of you updated a minor version and thought, right, I'm only updating to a new minor version, so it shouldn't break me, and it did?
They don't have a specific. I can count on two hands the times
it has
happened.
Right, yeah. But most of the fact that only one person, and I completely believe you, by the way, most of the time it doesn't happen, because most of the time these unwritten rules of, well, I'll assume that no one has done something stupid with overloads and method group conversions and things, even though you give you a way that I could have written code to break, would be somewhat contrived. But it kind of works, except for the diamond dependency problem that I think we really need to get on and fix. And I hope to, as part of the .NET Foundation, hope to put pressure on in that way. If JSON.NET ever does make an actual big breaking change, like, you know, maybe, for example, it's currently in Newtonsoft.json. That doesn't scream JSON.NET at me, so maybe it would be a good idea for JSON.NET version 14 to move everything to JSON.NET as the namespace. I see no problems with that plan. That would be a good forcing function, I think. But there's more that we can do, and I hope we will. But really, the main thing for you to take away is that versioning is important, and you need to think about it probably more than you have been doing before. If you go away with that message and tomorrow or next week or next month think about versions when you wouldn't have done otherwise, I'll be very happy. Please send feedback my way. You can tell me tonight as well, but chances are I won't remember it. If you email me, then it's got more chance of sticking for when I give the talk on Friday. But thank you very much. Are you after HDMI?
Yes, please.